we observe a population or random variable x with a PDF or TMF f small x theta, where theta is a parameter, is unknown parameter to estimate. Where theta is the unknown parameter. To estimate. And suppose that we select, we take a random sample. Consider random sample x1, x2, so on xn. And a sample x more 1, x more 2, x more n. We must classify the difference between random sample and sample. Sample is a factor and IID random variable, while sample is a factor and observation or n value. Okay, now we define an interval estimation. It's called 100 alpha confidence interval. We define 100 alpha confidence interval parameter theta is a random interval. Here by theta 1 hat, theta 2 hat, such as the probability parameter theta belongs to the interval theta 1, theta 2. The probability is 1 minus alpha. And 1 minus alpha is called the confidence level. And we usually consider 1 minus alpha is 90%, 95%, or 99%. Usually consider 1 minus alpha is 90%, 95%, or 99%. We have defined the confidence interval. Okay, I can show you the procedure to find 1 minus alpha CI theta. The first step, we find a point estimator theta is theta hat. And the second step, we determine the sampling distribution of theta hat. Function of theta. The third step, we find two values, maybe such as probability theta between theta hat between AB is 1 minus alpha, and then we change this equation, theta greater than theta 1 hat and theta 2 hat. Right? And then we obtain 1 minus alpha. 1 minus alpha ci theta is theta 1 hat, theta 2 hat. And we usually if the central limit theorem okay, the central limit theorem states that the statistic Z is x bar minus mu over sigma divided by square root of n. Is x bar minus z1 theta, sigma is z2 theta over square root of n. This statistic can to n minus 1. Okay, so we draw the graph of n minus 1 in PDF. PDF of n minus 1. And then we determine two values A, B, such that the probability between A and B is 1 minus alpha. And A and B are symmetric. Okay, so what is this area? What is this area? What's area at the right hand side B? This is the thinking of people at primary school. Xin biết không trả lời được các bạn học sinh đó. Alpha? No. Alpha is no. The total area is 1. So that's alpha divided by 2. Alpha over 2 and alpha over 2 is alpha. Alpha and 1 minus alpha is 1. Right? And this value is denoted by z alpha over 2. Z next is area at the right hand side. Right? So this value is minus z alpha over 2. Right? And the value z alpha over 2 is called the critical point. Critical value of C of n01 but never 1 minus alpha. It means that probability such that Z smaller than Z alpha over 2 or Z smaller than this point. The net area right is alpha over 2, so the net area is 1 minus alpha over 2. Right? And PC greater than Z alpha over 2 is alpha over 2. And this value is called the critical point, critical value. But never 1 minus alpha. Okay, so we have probability such that minus Z alpha over 2 smaller than Z is x bar minus Z1 theta divided by Z2 theta over square root of n smaller than Z alpha over 2 is 1 minus alpha. Yeah, this equation, and for this equation we shown theta belongs to theta 1 hat and theta 2 hat. Approximate. Okay, so here's the general theory for interval estimation. And now we apply the general theory to find the CI, the confidence interval of two parameters. The population mean divided by V and the population proportion divided by T. We consider the first problem. Problem 1. Consider the parameter theta is the mean is the px. Okay, so what is the question? What the question? We find 1 minus alpha ci mu based on a random sample x1, x2, so on xn. Okay, so for this problem, we will consider 3 cases. What are they? The first case, the name of the first case is case where the value sigma square is known. We know sigma square. If sigma square is a Vx, is known. And one of the two requirements satisfied. And x is normal or n is large. Yeah, the first case. The name of the first case is not values. Not values. And the second case. The course sigma is unknown. If sigma square is a unknown n, x is normal. And the third case, sigma square of course is unknown. And n is large. We will consider these 3 cases. Okay, now we consider the first case. We find the ci of mu when we know sigma square. First case, and we use this statistic. The parameter theta is v, so z theta is v. So the function z is identical function. Gx is x, and we know sigma. The first case, case 1. If sigma square is known and one out of the 2 requirement is satisfied, x is normal or n is large. Okay. Okay, now we use this equation. So the statistic z is x bar minus mu over sigma divided by square root of n for n01 or approximate. If x is not normal, but n is large, greater than 30, we can use the approximate. The statistically approximate the standard norm distribution. Okay, so we have determined 2 values. A is minus z alpha over 2, and z is b is z alpha over 2. And here is the variable z x bar minus b over sigma square root n between these 2 points. We have the probability tells us minus z alpha over 2 to z alpha over 2. This statistic is 1 minus alpha. Okay. And now we solve with the thinking of people at primary or secondary school. So some situation what know about what up about we greater than what? Tin tức học sinh tiểu học học cấp 2 đến tiểu học bây giờ học đúng multiply now the square root n with the left and the right side, so we have x minus mu greater than minus the alpha of 2 times sigma square root n smaller than. Okay, continue. We take x bar to the left hand side and to the right side. We have a minus mu greater than minus x bar minus the alpha over 2 sigma square root of n. Minus x bar plus and then we change the sign. Greater than and smaller than. We change the sign. Upper bound is x bar plus the alpha over sigma square root of n. Greater than, so the lower bound x bar minus the alpha over sigma square root of n. Okay, so what we have? Here theta mu1 hat, here mu2 hat. The lower bound and upper bound, so we make conclusion for the first phase. One minus alpha ci v is x bar plus minus epsilon. Epsilon is c alpha over 2 times sigma square root of n. Minus correspond to lower bound, plus correspond to upper bound. Where epsilon is z alpha over 2 times sigma square root of n. Next is called z error of the Ci. And if you draw the graph, it means with the value to estimate, so the first step we find a point estimator mean. What is point estimator mean? It's x bar. And 1 minus alpha ci mean is from x bar minus epsilon. Okay. The lower bound and the upper bound. This range is this distance is epsilon, so it's x bar plus epsilon. So the parameter mean comes from x bar minus mu to x bar plus epsilon, x bar minus epsilon to x bar plus epsilon. Epsilon is called the z error. Z error. Confidence interval. And what's the length of Ci? Is the epsilon plus epsilon. Is the 2 epsilon. So it's the 2 Z alpha 2 times sigma square root of n. Okay, in the first case, now we consider the second case. What second case? Now we don't know sigma. Sigma is unknown. And X is normal. Okay, so what happened? We copy the solution of the first phase. If sigma is unknown, of course we cannot use the z statistic because the z statistic depend on sigma. Sigma is unknown, so we don't use the z statistic. So how we do? We will replace the unknown sigma, the unknown variable. We replace sigma by its estimate. What's the estimate of sigma? What's the estimate of sigma? We study last week. Is không biết sigma là cái gì, không biết trong đầu một cái chữ gì, không có một cái chữ gì. We estimate V by x bar. We estimate sigma square by. There are two estimators of sigma square. They are ss square or s square. But we choose which? We choose which variance? We choose ss square or we choose s square? Why? Yes, because this estimator is unbiased. This emitter is biased, so we choose s square. So we estimate sigma by s, and we estimate p by ps. P the population proportion, estimate by random sample proportion. When we estimate, remember what is the theory of estimate? What is the theory of estimate? You replace population by sample. Mean is the population mean, estimate by random sample mean. Sigma square the population variance, estimate by sample variance. Standard population standard deviation is estimated by sample standard deviation. Population proportion estimate by sample proportion. So we will replace sigma by s, and the z statistic becomes the t statistic. The t statistic is x bar minus v. We keep x bar minus v over s divided by square root n. So what is the sampling distribution of the t statistic? The t statistic follow a distribution, namely the student distribution, denoted by Tn minus 1. Tn minus 1 is the student distribution. With n minus 1 degree of freedom. Okay, now we draw the student distribution with n minus 1 degree of freedom. Remember, the T n minus 1 is equal to n minus 1. Why? Because sigma s equal to sigma. So T n minus 1 equal to n to 1. If n is large. Okay, so T n minus 1 is also a symmetric distribution. Right? T n minus 1 is also a symmetric distribution. So which point A and B we choose? As point A, point B. This area is 1 minus alpha, so the right area, the right term and the left term has the same area, alpha over 2. Right? And this point is called T n minus 1 alpha over 2. And what the name of this value? minus Tn minus 1 alpha over 2. Let Tn minus 1 alpha over 2 be the critical value or point of the Steven distribution with n minus 1 degree freedom. Earth never 1 minus alpha over 2. It means that the probability such as Tn minus 1 smaller than this critical value is 1 minus alpha over 2. Right? The negative side is 1 minus alpha over 2. Okay, so from this graph, we have probability such as from A to B. So from minus Tn minus 1 alpha over 2 to Tn minus 1 alpha over 2. T is x bar minus v over s over square root of n smaller than Tn minus 1 alpha over 2 is also 1 minus alpha. Right? Okay, now from this equation, we have this statistic belong to the two values. Okay, now we solve. So what is the mean? We belong to which interval? What are different between the first and the second case? What are different between the first and second case between these two equations? We replace sigma by s and z by t minus 1. So what's the result? In this formula, yeah, you should use red color pencil, pen to note this formula, right? X bar plus minus z alpha 2 times sigma square root of n. So what is this result? X bar plus minus Tn minus 1 alpha 2 times s over square root of n. Right? We do similarly. Usually obtain the CI of mu. Okay, we make conclusion. 1 minus alpha CI v for the second case is x bar plus minus epsilon. So x bar plus minus Tn minus 1 alpha over 2 times s over square root of n. And the first and the second case now, we consider the third case. What third case? What the third case? N is large. If sigma is unknown n is large. Okay, so we will do statistics. We also use this statistic because sigma is unknown. X bar minus d over s divided by square root of n. Now you can guess the division of t in this type. What is the division of t in this case? When n is large, what happens? S very close to sigma. So t very close to is the standard norm distribution n01. Right? It's the approximate, it's not follow. Right? So the first case, when x is normal, if x is normal, standard normal, and if x is not normal, but n is larger, then r approximately n01. Right? So it's the approximately n01. Right? So we choose two values, minus z alpha over 2 and z alpha over 2. We have this statistic. So what the result? What the interval mean? CI mean? Ready? You take x bar plus minus z alpha over 2 multiplied with s whole square root of n. It's 1 minus c. Okay, so 1 minus ci 3, 4, 3 is x bar plus minus epsilon, so x bar plus minus z alpha over 2 times s over square root of n. Right? Okay, so can you summarize the data? We summarize the formula of CIFP for 3 cases. As a summary. One minus alpha ci 3 is x bar plus minus epsilon, where epsilon is z alpha over 2 times sigma square root of n, when we use sigma, if sigma was minor, and what? And x is normal, or and is not greater than 30. Right? So second case, what epsilon is the second case? You replace z by Tn minus 1. Tn minus 1 alpha over 2. You will replace sigma by S. When we use this form, sigma square is n. X is normal. The first requirement. The second case, the first case. Okay, z alpha 2 down s over the n. When we use this case, if sigma is unknown and n is large, okay, greater than 30. Okay, so remember that when we know sigma, we use sigma. Right? When we don't know sigma, how to do? We replace sigma by s. Right? And if x is normal, sigma is unknown, we use the Steven distribution. The second thing. Only second case, we use the Steven distribution. The first and the third case, we use the standard norm distribution n01. Right? Okay, now we do an example. And this is the example. Does this come? Question ABC, have we done question ABC? No. Have you tried to exercise point estimation? Trước làm cái gì? Trước bài tập ta làm cái gì? Tập chưa ước lượng điểm lên trước cái gì? There you answer question A, B, and C are three questions of point estimation. So you answer question D and E. Well, firstly you read the problem. The following measurement will record for the right time in our certain range of time space. The first observation is 3.4 hours, the second 2.5 hours, and so on. The last one 4 to 8 hours. 2001 number of observations. That's it. 1, 2, 3, 4, 5, 6, 7. Okay, so the 14 and 1 is the 15. The sample size is 15. And then, as a result, the measurement represents the range of circle from along the population and with sigma square, where sigma is supposed to be 0.9. So, we know sigma, we know sigma is 0.9. And the population X is a normal. The keyword in this question, normal. So, we are the first step. Yeah. We know sigma and we know X is normal. Question D. Find 95% confidence interval estimate of V. So we have the confidence level. 1 minus alpha is 95%. Right? Okay. So question D question is not difficult. You only copy the theory. Copy the theory to give the formula and then you compute the formula for this sample, for this 15 observation. So now we have to wait 10 minutes and then we correct